All right, today we're going to do a second day of looking at combining lessons 5.3 and 5.4, which are proving triangles congruent using one of our four different properties that we've had, which is side, 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 angle, or angle, angle, side. Today's work, we're going to bring in some ideas, some more added information about parallel or perpendicular lines. What if they are given information? How do we use that? We're going to work with the concept of congruent parts, or excuse me, corresponding parts of congruent triangles are congruent, which is the CPCTC you see listed there, and then also the hypotenuse leg concept. How do we use that? So we're going to add all that in today and still be working with the concept of proving triangles congruent. So the first thing I want to look at is, let's look at a proof in which they give us information about parallel lines. So there's the difference. This is why we're doing this today. Notice that right here in the given, it says that AB is parallel to DE. So how do we use that given to get us information so we can prove triangles congruent? Okay. Well, first thing I'm always going to do is redraw it so that I can add what I want to it and see exactly what I'm given and what I can prove. All right, the first thing you see as a given is that C is the midpoint of AD. So if C is the midpoint of AD, okay, that means the distance from A to C and the distance from C to D are the same. So those two are congruent. Now, just because C is the midpoint of AD does not mean you're allowed to assume it's also the midpoint of BE. All right, you can only do what they give you. You can only make conclusions based on what they give you. You can't make up others. All right, so this is all I get from that first statement is AC is congruent to CD. Now the second given tells us that AB and DE or ED are parallel to each other. Now remember, we put these triangles through lines that are parallel. So this line is parallel to this line. Now, what does that do? Why do they give us that information? Well, what you want to see is AD is a transversal that goes through the parallel lines. And in any transversal, we know alternate interior angles are congruent. So what that does by telling us the lines are parallel is it gives us alternate interior angles to be congruent. Now, actually, BE is also a transversal. So this angle and that angle are also alternate interiors to those parallel lines. So I get both of those facts based on just being telling me that AB is parallel to DE. Now, as far as proving the triangle's congruent, I have enough. I got angle, angle, side, angle, angle, side. So that's all I really need in my proof. Now we got to lay it out. And you have to list the given. So I have to list that C is the midpoint of AD. This information lets us say that AC is congruent to CD by the midpoint property. Okay, so you got to enter that in before you can use a fact about it. So we got to enter this in, and then based on that, I can make this conclusion, which is one of the things I needed. And then I'm going to say angle, the measure of angle A is equal to the measure of angle D, because if lines are parallel, alternate interior angles are congruent. The measure of angle B is equal to the measure of angle E. If lines are parallel, alternate interior angles are congruent. And guys, I just noticed that I made a mistake. I should have entered this into my givens. So my step three should have said AB is parallel to DE as a given. And then I'm going to use that given to make these two conclusions. So that's a mistake on my part. You're going to have that to get it right tonight. You're going to have to enter AB as parallel to DE before you make these conclusions. Now, notice I wrote it like this: the measure of angle A equals the measure of angle D. Okay, measure of an angle is a number. So I'm saying a number equals a number, which is true. Now, if I didn't want to put the M on there, I could say angle A is congruent to angle D. Okay, so that's when you use equality when it's a number, you use congruency when it's a figure. Okay, but they mean the same thing. They can be interchanged. All right, so once I've gotten this statement, which is my sides that are congruent, and these two, which are the two angles I needed, now I can say the triangles are congruent by angle, angle, side. But again, I should have entered that in as a given, guys. I made a mistake there. I hope I didn't do it again, but there's a chance I might have. Okay, you don't make that mistake. I did. All right, another one that's very similar. I just want to show you how we could have done this differently the first time. All right, again, they tell us R is a midpoint of PS. They tell us that two lines are parallel, and we're trying to prove the two triangles are congruent. So let me bring it over here. and enter in information. Now it says R is the midpoint of PS. That means P to R, R to S, same length. And that's all I get. I can't make any other conclusion. That's direct conclusion based on this. They then tell me PQ and ST are parallel. All right, now what does that do for us? Well, it does the same thing. I know that this angle is congruent to this angle. Now, let's say I want to go a different direction here. I could say these two are also congruent and get angle, angle, side, or based on the drawing, I could say I got vertical angles here. That's true. They're congruent. And now I prove the triangle is congruent by angle, side, angle. So again, I could have went angle, angle, side like the last one, but this time I chose to put, vertical angles in and go angle, side, angle. Just works out either way. That's why I said there's a little bit of freedom here in how you can do some of these. So that's how I'm going to prove it this time. So I'm going to go R is a midpoint of PS. That's a given. That allows me to say PR is congruent to RS by the midpoint property. Okay, and I boogered it up again. I should have put this given in line 3. Bad by me. PQ is parallel to ST. That should have been here. And then from that given, I got angle P and angle S are congruent by the fact that if lines are parallel, alternate interior angles are congruent. All right. And then I decided to say that these two angles, which is I got PRQ and TRS, these two are congruent by vertical angles. And now I prove triangles congruent by angle, side, angle. So it's the same kind of problem. I just did it two different ways. And sometimes you'll have that flexibility where you can do it like that. All right. So it all depends on what you see, and then just follow our properties. Okay. Now, the next idea is this hypotenuse leg concept. Okay. Now, hypotenuse leg property, congruence property, allows us to say that two triangles congruent if they're right angles. Number one, they both have to be right angles. And if we know the hypotenuse, which in this case would be DE and BC, it's the side across from the right angle. If I know the two hypotenuse sides are congruent, and I know a leg is congruent, so EF and BC are congruent, then that's enough for us to say the two triangles are congruent. Now, take this triangle, guys, and rotate it down, and it'll match up exactly. So don't be confused by that. Now, why does the hypotenuse leg property work? Well, really simple. It's based on side, side, side. Okay. Because what can we do with a right triangle? Well, we can use Pythagorean theorem to find the missing side. And if this side and the hypotenuse are the same, and these two are the same numbers, then when I do Pythagorean theorem, I'm getting the same answer for the missing side. Therefore, if I know the hypotenuse and a leg and it's a right triangle, the third side's got to be the same by Pythagorean theorem. That only works with a right triangle. All right. So really, hypotenuse leg is an extension of side, side, side. Okay. But for us right now, when we see we have right triangles, now we know rather than having to do a different proof, which we could maybe have a different one here. We can prove right triangles congruent using side, 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 angle, side, angle, side, angle, 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 side. We can use any of those. But if we see this, we can always use this little shortcut here. Okay. I guess my point is you don't have to use this. It's an option for a right triangle. All right, let's look at this first one here. So we're trying to prove that A, what is it? ABD. So the triangle on the right and CBD, the triangle on the left, we're trying to prove these two are congruent. We're told that ABD and CBD, we're told that these two are right triangles. So they're giving us this little right angle here, and they're telling us that AD, this side and this side are congruent. We're trying to prove the triangle's congruent. So I'll redraw it over here. Now, they already give us an angle. Okay, so I got an angle here. Now, they tell us that CD and DA are congruent. We know by the drawing that they're sharing this side DB between the two triangles, so that side's congruent to itself. Okay, so I got DA and DC, which are the hypotenuse of their triangles. They're the side across from the right angle. I have this side, which is a leg. The two sides that make up the right triangle are the legs. So I have enough then to prove that these two triangles are congruent by hypotenuse leg. So one key fact is We have to know that the two triangles are right triangles. We have to know that those are right angles in order for us to use this property. So we have to have that entered in our proof. Okay, and that was a given. AD is congruent to CD. That was a given. DB is congruent to DB. We know that to be true because of the reflexive property. So that's what we needed. We needed three facts. We needed the fact that they were right triangles. That's one. We needed the hypotenuses to be congruent. That's the second piece I needed. And then I needed a leg to be congruent. That was the third. If I have these three pieces, then I know the triangles are congruent by hypotenuse leg congruence property. Okay. Next one here. Same deal. We want to use the hypotenuse leg property. We're going to prove SQR. That's the bottom one, if you will, and SQP or QSP. Sorry, the top one here, if you will. We're trying to prove these two are congruent. Now, notice they tell us the triangles are right triangles. That's a big clue for you. And they give us a set of sides that are congruent, PQ and RS. So if I go over here, they're telling us they're right triangles, so I know I got right angles in here, so that makes them right triangles. Okay, they're telling us that what is it? PQ this side and SR this side are congruent, the same length. They share SQ, and SQ in this case is the hypotenuse for the two triangles. It's the hypotenuse for each of them. So I have right triangles, and I have a leg, which is a side that's not the hypotenuse. I have a leg congruent, and the hypotenuse is congruent. So I can prove those triangles by hypotenuse legs. So I'll enter the first piece of information, which we have to have. We have to know that they're right triangles. PQ congruent to RS, that was a given. SQ congruent to SQ, that's reflexive property, and that's the hypotenuse. So there's my three pieces of information I need. That's enough to say the triangles are congruent by hypotenuse leg. Okay. Okay, the last new concept for the day is this corresponding parts of congruent triangles are congruent property. All right. And this property basically says that once we've proven two triangles are congruent by our theorems, by side, 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 angle, side, angle, angle, side, angle. Once I use one of those shortcuts to prove two triangles congruent, then we can say any of the other three corresponding parts have to be congruent as well. Because once I'm proved two triangles are congruent, that means all six parts are congruent. So anything I haven't named in the proof, I can conclude that's congruent now. So let me just kind of give you an idea here. So let's say we were given this diagram. Now look at what we're trying to prove. We're not trying to prove the triangle's congruent. We're trying to prove that RU and UT are the same length. Okay, well, I'm not given any direct information about those. But what I'm given in the drawing is I'm given the ability to prove that triangle, how do I name it? RSU and TSU. I can prove these two are congruent to each other by side, angle, side. Okay. So once I prove these two triangles congruent to each other by side, angle, side, then I can say that RU has to be the same as UT because those guys are corresponding parts. These two parts, these sides match up in the congruent triangles. So they're corresponding parts of congruent triangles. So they have to be congruent to each other. Now I could have done the same thing with angle R and angle T. They have to now be congruent by CPCTC. And RUS and TUS, those two angles have to be now congruent by CPCTC. So you can conclude any of the three missing pieces are now congruent. All right, so that's CPCTC. You're going to see that used. Now let's go ahead and look at a problem that involves that. So notice now, this looks just like the other problems we've done, but they're telling us they want us to prove that QR is congruent to SR. So they want us to prove QR and SR are the same length. All right, and here's our given information. All right, so let's go ahead and take our given information and put it in our drawing. Okay, so PRQ, this angle, and PRS, those angles are congruent. That's a given. We're told that PQR and PSR, those two angles are congruent. All right, we're not given any information about the length of QR, the length of RS. Okay, that's not going to help us now. But what we do know, looking at the drawing, is that PR is congruent to itself. So I could prove the two triangles congruent by angle, angle, side, angle, angle, side. And if I can prove the two triangles are congruent, I know QR and RS have to be the same length also, but because they are corresponding parts of the triangles I just proved to be congruent. So what happens now is we're going to go through our proving our process the same way. All right, I got a given. I got my second given. Those are the two angles I need. I have PRs congruent to PR by reflexive. These three facts allow me to say that the triangles are congruent by angle, angle, side. And if the triangles are congruent, then these two pieces or these two sides of my triangles are also congruent because they are corresponding parts of congruent triangles. So they have to be congruent. Okay. So now proving the triangles congruent allows us to make a conclusion. And that's what we want to do. Okay. Let's look at another one here. So now again, if you look at what we're trying to prove EFD, this angle right here, and GDF, this angle here. We're trying to prove those two are congruent. Okay. The way we're going to do it is we're going to actually prove the two triangles are congruent, and then those two are corresponding parts. So let's bring our drawing over and start labeling what we know. DF is congruent to FG. So I know those two sides are congruent. I know angle EDF and angle GFD are congruent. EDF and GFD. So I got these right here, right? I also know in a drawing that DF is congruent to DF. Okay, remember what we're trying to prove is EFD, this angle down here and this angle up here are congruent. Well, I can prove the two triangles are congruent now by side angle side, side angle side. And since the two triangles are congruent, since these angles correspond to each other, they have to be congruent. So just go about your business here proving it. Given that's a side length I needed, given that was an angle I needed, we know DF congruent to DF by reflexive. Those three facts lets us say the triangles are congruent by side angle side. Be careful here how we write this. We got to match up corresponding parts. Okay. Now, once I prove the triangles are congruent, I can now prove this pair of angles are congruent because they are corresponding parts of congruent triangles. So you're going to have some of those to work on tonight. Okay. So that takes us through all of the work we're going to do on these, on proving triangles to be congruent. Okay. So we've added some extra things into our basic four properties, the idea of parallel lines or perpendicular lines or, the hypotenuse leg concept. So we got a bunch of things there you can work on. Okay. Homework follows the examples really close. And, that just make sure you're working at it, writing things out, and I will let you get after it.